All right, so let's be interactive. Why you are having issues you can't understand, please communicate so we can figure out it. Is that clear? Okay.
Yes.
All right, let's get into it. So question 2, just a moment. Question 2 on the paper, section B says, given the following results, indicate what will happen to the beta for Sophie fashion company relative to the market proxy compared to the beta relative to the true market portfolio. So we are given our yearly returns here, our yearly rate of return here, with the years in the first column. Sophie's returns are here, market proxy is here, and the true market is here. So based on these tabulations we're given here, right, we are required, firstly, to discuss the reason for the difference in the measured betas for Sophie Fashion Company. Discuss this. So how do we handle such a question? Just a moment, interested here. So to explain such a question, with data is already tabulated for us, right? So we use the following notions. RS, we denote returns for Sophie, according to the returns for Sophie. RM will be market proxy returns. And then the other one, last one, we'll say RT for the true market returns. RT, true market returns. So this is Sophie returns. We're just creating our denotions here first. Sophie returns, market proxy here, market proxy, then here the true returns here. The true returns will be given here. So the first thing we're going to do here, right, is we need to find our average returns for each of these conditions given to us. So we'll start with the first one. Sophie's average return, RS bar, which would be equal to the summation of whatever is here. So what are we getting when you add everything that's here? Can you add this for me, please? Can you add this for me? What are we getting when you add this? What are we getting? What are we getting? Hello? What are we getting when you add this?
11, I think.
Yes, 11. That's right. So when you get 11 over 5, which should give us, because 5 is the number of years, which is going to give us 2.2% as the average return for, yes, as the average return for Sophie. Now, let's find the average return for the market proxy, RM bar, which would be equal to the same procedures executed. So I'm going to add this 8 plus 14 minus 10 minus 18 plus 12. We're getting 6 over 5. 6 over 5, giving us a market return of what? 1.2%. This is the market return for the market average return. Now, the average true return here, RT bar, will be equal to the following. So we're going to add everything that's here again. So 6 plus 11 minus 7 minus 12 plus 10. It's giving us 8. We're now saying 8 over 5, which will give us what? 1.6% as the average return here in this case. How this is obtained so far? We're okay here? Are we all comfortable?
Yes.
Okay, yes. Now, keep in mind, for us to find our beta, we need to compute our covariance. So to compute covariance here, what we're doing is saying covariance of S and P, right? Sophie and the market proxy now. We find covariance in Sophie and the market proxy. We find the covariance in Sophie and market proxy. Because we need the covariance to denote our beta for Sophie and market proxy. Because beta, Sophie, and the market proxy, right, will be equal to the following formula. Write it down here. So beta will be equal to covariance between Sophie's returns and the market proxy returns over the variance of the market proxy. This is all we need so far. So based on the formula, because of what we have in the formula here, We need to compute our variance as well as our market proxy, our covariance here in this case. Are we okay here? We okay?
Yes.
All right, okay. See? So at this point now, we now start finding our covariance, right? So we need to find the covariance between SOFI and the market proxy. So covariance between SOFI and market proxy will be denoted as follows, right? We're going to say this will be equal to the summation of the returns of SOFI minus the mean return of SOFI also, average return of SOFI, times the returns of the market proxy, which is we're calling RM for us here, returns of market proxy minus the average market proxy return, then over n minus 1. This is our covariance formula. Any questions regarding the formula? Are we all comfortable with the formula? Are we all comfortable?
Yes.
Okay, great. So at this point now, we then tabulate the information. So the best option I can advise is for us to solve this faster, right, is to tabulate this entirely. We use a tabular format when solving such a question. So I'll draw a table which I'm going to be using here. So I'll draw a table here. So our table will have the year in the first column, Y. Then we're going to have the return of SOFI minus the return of the market, minus the mean return of SOFI, minus mean return of SOFI here, RS bar. So we're going to have the market proxy return, RM, minus the average market proxy return, RM bar here. In the last column, we have the product, return of SOFI minus the market average return of SOFI multiplied by the return of the market proxy minus average market proxy return. Any questions so far? So we're going to start with year 1, year 2, year 3, year 1, year 2, year 3, year 4, and year 5. So now let's find our individual returns, right? So here, what are we doing here in this case? We already have our market returns for SOFI fashion here given to us, right? So I'll say in 10, the first one is 10 minus 2.2. So I'll give a demo here, how it's coming by. So I'll say in 10 minus 2.2, giving us 7.8. Are we clear here? How's this coming by? Are we all clear? Are we getting 7.8?
Yes.
Okay, so based on this now, we apply the same concept to this. So 20 minus 2.2 give us 17.8 here. 17.8. And then we're going to now say 14 minus 2.2, negative 14 minus 2.2 give us negative 16.8. Sorry, 16.2. Negative 16.2 here, 16.2 negative. Then here we're going to have the next one is negative 20 minus 2.2, which are going to give us negative 22.2, negative 22.2% here as the return here. And then last one for this one is going to be 15 minus 2.2, 15 minus 2.2, which is going to give us 12.8 as our return here. So having found this, okay, so having found this, right, we then proceed to finding the difference in the returns of the market proxy minus the market proxy average return. So market proxy average return was found as what? As 1.2, right? As 1.2. 1.2, right? So now, I'm going to now find it based on 1.2. So I'll say the first one, for the first one, it will be the individual return, which is 8 minus 1.2. What are we getting here? Are we getting 6.8, right? 6.8, are we following?
For the one you're working out, the title is what? What's that? RM?
RM is the return on the market proxy. Remember the notion I gave you that one here? Market proxy return. This one here. So RM is the return on the market proxy.
Okay, but it's minus what? RM minus RM.
What the measurement? So yeah, it's market proxy return here. So RM minus RM bar, which is average market proxy return here. Average market proxy return.
Okay.
Yes, so based on this now, based on this, we'll now say next time is going to be what? The 14 minus 1.2. 14 minus 1.2, what are we getting? 12.8, right? We're getting 12.8 here. So we're saying 12.8 for this one. The next time is going to be negative 10 minus 1.2, which is going to give us negative 11.2. And the following one is going to be negative 18 minus 1.2, which is going to give us negative 19.2. And the last one, our last one is going to be 12 minus 1.2, which will give us 10.8. Any questions so far, everybody else? Any questions? Are we all following? Mr. Francis, Madam Gertrude, are we all following?
I'm following, sir.
Mr. Chiwanza, are you following?
Yeah, I'm okay.
Madam Gertrude?
Following.
Okay, great. So at this point, right, we then find the product between this and this together, this column here. So 6.8 minus times 7.8, what are we getting? Help me out the products here. 6.8 times 7.8, what's it giving us? 53.04, right? This is the answer. Are you getting this answer? The next one will be what? Next one will be 227.84 here. Next one, 16.2 times 11.2 give us 181.44. The next one is going to be 22.2 times 19.2, sorry, will give us 426.24. And last one will be 12.8 times 10.8 to give us 138.24 here. So what's the summation of all this? Can you add this one, please? Tell me what you guys find answer.
1026.8.
1026.8, right? 1026.8. Any questions so far? Are we all following? So this 1026 is what we would coin as our covariance. As our covariance for stocks and the market proxy. This is our following here. Are we okay so far? Are we okay? Yes, so far? It's just not full covariance itself. So covariance now in this case. Remember the formula I gave you before? Said covariance is equals to what? Summation of it. So this one is our summation here. This is our summation. So covariance now, covariance of S and the proxy will be equal to the 1026.8 over n minus 1, right? 5 minus 1 over 5 minus 1. Are we clear so far? Are we clear so far? Are we clear?
Yes, we are clear, sir.
Hi. So
Yes. Yes, go ahead, please.
so I'm not clear on one stage. In the
Yes.
formula, you indicated that it's supposed to be divided by, is it the variance
No, that's
or
for the
n minus 1?
yes, for covariance, yes, here. N-1. And for the variance, that's the beta coefficient, now the beta itself. We haven't done the beta part yet. We're just finding the
Okay,
covariance
okay.
first. Yes, so what are
Okay,
we getting?
understood.
Yes, so what are we getting here? Let's say 102 now. 1.8 over 4. What are we getting the answer here? That's our answer.
256.7.
256.7. So this is our covariance between Sophie's stocks and the market proxies returns. So having found the covariance, right, we then now rush to find the variance on the market proxy. Remember, we need to find the variance of the market proxy formula here. Variance of the market proxy. So now looking at variance market proxy. Variance of proxy now. So to find the variance of market proxy, right, we already have one vital element. Remember, we say variance is equals to summation of Ri minus, so Rm in this case, market proxy minus Rm bar squared, right? This is how we use it generally. Then over n minus 1. Over n minus 1, right? Are we okay with the formula here so far?
Yes.
So we're now going to go back to our table, right? Since we need this Rm minus R bar, right, we already have the figures here. So all we need to do is simply square these figures here. Square these figures. So I'll write it down here. Rm, return of market proxy, return of market proxy, minus return of market proxy minus average market proxy return here. So here, and then the square of this now, Rm minus Rm bar squared. So generally here, right, we already have this given to us. We already found this here. We found them as 6.8, first one was 6.8, then we had 12.8, then we had negative 11.2, negative 11.2, and negative 19.2. The last one was 10.8. So we still find the squares of the square values here. We now square these figures here. We're now squaring these to get answers here. What are we getting? What are we getting after squaring them? What are we getting? 6.8 squared. What are we getting? What are we getting?
46.24.
46.24, right? 46.24. 46.24. The next one?
163.84.
163.84. 163.84. 163.84. Okay, and following one? And the following one? Sorry?
125.44.
Yes. Then next one?
368.64.
368.64. Yes, following one?
116.64.
One shot?
116.64.
116.64. 0.64. Then what's the summation of all this now? What's the summation of all this? What's our sum of all this, our sum total?
Mhm.
820.8.
820.8, yes. Yes, on the right path, 820.8. So this is just the summation of what we need. So our variance now in this case would be equal to the 820.8 over 5 minus 1, which is now going to give us what? What are we getting? We're now saying 820.8 divided by 4. It's giving us 205.2, right? As our variance. 205.2 as our variance. Are we all following? Are we all on the same page? Are we all following?
Mhm.
Any questions here so far? Any questions so far here? Any questions? Questions? Suggestions? Questions? Are we on the same page? Are we all on the same page?
Yes.
Okay, so now to find the beta between Sophie's stocks and the market proxy, we're now saying it's our covariance, right? Which we found at what? We found covariance is 256.7. So it's going to be 256.7 over the market variance, which is 205, sorry, 0.2. What's our final answer here? What's our final answer? Can you open up the final answer there?
One point 25.
1.25?
Yeah,
1.25. This is the beta between Sophie and the market proxy here now. Are we okay so far? Any questions? Any questions so far? Or suggestions? Questions or suggestions? No questions. All following? Great, that's wonderful. So at this point now, having reached this point, right? We then do the same thing for the true market basis now. We repeat the same procedure under the true market approach now. Under the true market approach. I was just trying to look at the differences in the beta coefficients. So I'm now trying to look at the true market approach now. Are we okay so far? So remember we did the first one, we started by finding. So again, we're now going to find the beta between Sophie and the true market approach here. The beta between Sophie and the true market approach here, which is now going to what? The covariance of Sophie and the true market over the variance of the true market here. Over the variance of the true market here. So we now find the beta based on this, right? Now keep in mind, we don't have to start doing the whole thing from scratch. Where else now find the whole difference in the Sophie stocks and the return of Sophie. We can just do the same thing. So for Sophie stocks, keep in mind, we already found Sophie stocks, right? We found this here. We found this here. Is it okay if I erase this part? Can I erase this part? Have we written this down? Can I erase this part? Am I able to erase this part? Am I okay? Can I erase this part?
Yeah, it's okay.
Okay, so I'm erasing this part here. also going to erase this part now. And this too. So that's this here. So now we already have SOP's data here, right? Our focus is now on the true market approach. So we're going to find the return of the true market minus the average return of the same true market. And then here, same concept applies, return of true market minus average return of true market here. So at this point, right? At this point, what do we now do? The same concept we applied here. So now our finding, remember, our true market return, average return of 1.6 here, right? So I'm now going to say the first one is going to be the 6, right? 6 minus 1.6 to give us what? It's going to give us 4.4, right? 4.4 here, 4.4. The next one is going to be 11 minus 1.6. Are we getting 9.4, right? We're getting 9.4 here. So 9.4. The next one is going to be negative 7 minus 1.6 to give us negative 8.6. Negative 8.6. Then negative 12 minus 1.6 give us negative 13.6. The last one will be 10 minus 1.6 to give us 8.4. Now we need to find the product between this and this. The product between these two, between this and this, the products now, our products here. Our products. Before I get to volume, just create space in advance for the other things that we need. Sorry about that. Let's create space for now we need here. So I'll create an extra column just for us to note down the variance. So this will be our RT minus R bar squared. This will be RS minus RS bar times RT minus RT bar. So now we're saying 7.8 by 4.4. What are we getting? 7.8 by 4.4. What are we obtaining as our answer? What's our answer? What's our answer?
34.32.
24.32.
34.32.
Okay, 34.32, yes. 34.32, yes. The next one should obtain 17.8 by 9.4. We're getting 167.32, yes. Then 16.2, negative 16.2 times negative 8.6, obtain 139.32 again here. Then 22, negative 22.2 times 13.6, negative 13.6 again, positive 0.92 here. Then 12.8 times 8.4, we're getting 107.52. Can you add this for me now? What's the final answer I'm getting here? What's our final answer? What's our final answer? What's our final answer there?
$745.4.
Sorry?
745.4.
745.4. So I'm getting. Are we on the same page? Are we on the same page? Okay. So 745.4. So 745.4, right? 745.4. So at this point here, at this junction, at this point we've reached here now, right? We're going to say, we need to find the covariance, right? So covariance between SOPs and the true market stock is going to be 745.4 divided by 4, was n minus 1. So divided by 4. So 345.4 divided by 4. What are we getting? Are we getting this? 186.35. $186.35 is the answer. Are we okay here? Are we okay here? Okay. Are we on the same page? Are we all on the same page here?
Yes, sir.
Okay, so having found that covariance, right? We didn't find the variance of the true market. Variance of the true
Sorry.
market. Yes, sir. Yes, sir. Go ahead, please.
Yeah, sorry, let's go scroll back to the table.
Table. Yes, so I'm going back right now. Here. This table here.
139. The summation I'm finding is 750.4, not 745.
Okay,
Unless I'm doing something wrong.
okay, just a moment. Let me add 2. Zero 1.92 107.52. Yeah, 750.4. Sorry about that. 750.4. 750.4. Thank you for the correction, Mr. Chiwanza. So having done this, right, we then go back to our covariance, but the concept of the same concept is given. Same concept. So I say divided by 4. The only change is going to be here. So I say 187.6 here. 187.6 here. 187.6 as the answer I'm getting here. 187.6 as the answer I'm getting here. Are we okay so far? Are we okay so far? Are we
Yes.
okay so far? Okay, so we've obtained this as a covariance, right? Let's now find the variance. So we'll go back to the same table. All we're doing here is we're simply squaring the figures here. So 4.4 squared, 4.4 squared will give us 19.36 here. 9.4 squared will give us 88.36. The negative 8.6 squared, negative 8.6 squared will give us 73.96. And then negative 13.6 squared will give us 184.96. And last one, 8.4 squared. 8.4 squared will give us 70.56 here. So what's the summation of all this now? We're saying 19.36 plus 88.36 plus 73.96 plus 184.96 plus 70.56. We're getting a total of 477, sorry, 437, 437.2 as a summation of this part. So we now know that our variance will be computed, right? Computation of variance. We say variance will now be equal to the 437.2 over n minus 1, which is just 4 now here. So divided by 4, we're getting 109, which is going to be equal to 109.3, 109.3. So therefore, beta will now be equal to 187.6 over 109.3, which is going to give us what? 1.72 as the beta here. As the beta here. Are we clear here? Are we all clear here how this came by? Are we all clear how this came by? Anyone behind so far? Anyone behind? Are we on the same page? On the same page, right? Lovely, great. Like that. So having obtained this beta, so beta between Sophie and market proxy was what defined for? We found 1.25, right? Beta so like 1.25, and beta between Sophie and true market is 1.72. So based on these two factors here, right? Based on these two factors here, we can now answer our question. So we can now address our question further. So now, why is there a difference between the beta and this, right? Since we found the beta, we know the beta for the market proxy will be higher compared to the beta for the true. To compute beta relative to market proxy, beta is lower. So you can see that the market proxy, why is there a difference? This is because the market proxy is simply a subset of the total market and not the theoretical market portfolio used in Iapm. So this may be because it's more or less volatile than the true market and may miss some certain elements of diversification. So if Sophie tends to correlate more with the proxy than the broader market, the beta with respect to the proxy will be overstated. Are we clear here? Are we clear?
Yeah, maybe we can just write it down, sir.
Okay, I'll see if I can type it out. Okay. So we are able to see here. Are you able to see this? Are you able to see this? Are you able to see this? Are you able to see? Use red ink. Okay, great. We can all see this, right? Can we all see this?